So number 4 is kind of nice. It's really already factored for you, but I want you to see that this is going to be a repeated factor. So you have to set it up just a little bit differently. So this fraction, setting it up with partial fraction decomposition is, and again, you don't have to do it necessarily in the order I am, as long as you have right amount of fractions with constants on top of it, we're okay. As in if you put a over x plus 4 and b over x minus 1, that's okay. All right, so I have those setups. I only get 2 convenient values because I only have 2 factors. So I have x is equal to 1 and x is equal to negative 4. So again, I take this, and this is where most students make a mistake. You're multiplying each term. I'm going to write it out like I do my baby algebra class. X minus 1 squared times x plus 4. X minus 1 squared times x plus 4. X minus 1 squared times x plus 4. And same thing over here. Okay, you're multiplying everything by that common denominator and reducing. That's going to reduce, and you're going to get 1. Here, that reduces only one of them, and you're left with those 2 factors. Here, all of that goes, and you're just left with x plus 4. The x plus 4's go, and you're left with x minus 1 squared. Be careful on the algebra. All right, so look, I have 3 constants I need to solve for, but only 2 convenient values. So I'm going to have to do something else to get that 3rd value. But let's get what we have. So if I put in 1 everywhere there is an x, I get 1 equals b times 5, so b is 1/5. So yes, I'm not writing out every little step now. Hopefully you can see where you're going to get those zeros. Okay, if I let x equal to negative 4, I'm going to get 1 equals a times 0, and I'm going to get a 0 there, and then negative 4 minus 1 squared. So that's going to be negative 5 squared, which is positive 25. So now I have everything except a. So you have some choices. How do I get a? Lots of different ways, again, to go do this. I'm going to use that process talked in my previous videos about equating coefficients. So I look back up here and I go, well, a, if I FOIL this out, that's going to be x squared, let's see, plus 3x minus 4. So a is going to be multiplied by x squared, by a term with x, and by constants. So you can use any of those to equate coefficients, as in the x squares, the x's, or the constants. It really doesn't matter. Okay, I'm just going to pick the x squares. Okay, so if I equate the x squared coefficient, I'm looking at this equation. Looking on the left side, I have 0 x squared. On the right side, I'm going to get a x squared. No b's. And this one, that's going to be x squared minus 2x plus 1. So that's going to be c x squared. So they all have an x squared, so just looking at the coefficients, 0 equals a plus c. I have c. So that tells me that a is negative 1/25. You could have picked the x's or the constants. You're going to get the same exact answer. All right, so we are now ready to integrate this problem. So we had 1 over x minus 1 squared times x plus 4. Okay, so that equals to a. I'm going to go ahead and pull that outside the integral, over 1 over x minus 1, plus b. b was 1/5, and that's 1 over x minus 1 squared, plus c, and that was 1 over x plus 4, I believe. All right, so how do we integrate these three? So this one's easy, this one's easy. This is not the natural log because of that squared. So we're going to have negative 1/25 times the natural log of x minus 1 plus 1/5 times the integral of x minus 1 to the negative 2. And then we have another natural log. Okay, so now here I have to use the power rule. Okay, so I'm going to have 1/5 times x minus 1 to the negative 1 divided by negative 1. And then I just have to clean that middle thing up because it's just ugly. And so that is how you do a problem with repeated linear factors. Okay. This next problem, again, it's already in factored form for you. This factor is quadratic, but you cannot factor it any further. It's the sum of two squares. That does not factor. Right? So how do we set this fraction up? Well, I'm going to put a on top of my linear factor, but bx plus c on top of my quadratic factor. So I'm kind of taking a shortcut, not writing another line, and just saying, okay, this fraction equals to these two, multiplying everything by the original denominator. You're going to get 3x squared minus 4x plus 5 equals a times x squared plus 1, and this is where you've got to be careful with those parentheses. Put the bx plus c in parentheses so it all gets multiplied to the x minus 1. Okay, here's the bad news about quadratics. You don't get a convenient value. You just get it from the linear factor. If you set that equal to 0 and solve for x, you're going to get plus or minus I. Don't use that. We need real values. So I'm going to use the only one I have. Everywhere there is an x, I put a 1. So that's 0. So this is 3 minus 4 is negative 1 plus 5. That's positive 4. So I know A is equal to 2. But I've got two other constants to solve for, B and C. So this is where, again, you might want to FOIL this out. Okay, so I'm going to have bx squared minus bx plus cx minus c. All right, so I need b and c. So b has an x squared and has an x. C has x's and constants. Again, just pick and see what works. Right? You might not like what you pick, and then try something different. I'm going to try the x squares. So I've got 3x squared on the left, ax squared plus bx squared. So I have 3 equals a plus b. Well, this is good news because I have a. That means I can figure out what b is. Okay, so now I still need c. So I either need to pick the x's or the constants. Okay, if I pick the x's, on the left I have negative 4x. There's no x's with a's, but I have a negative bx and a cx. So that's negative 4 equals negative b plus c. That's okay. I now know what b is. But what if I had done that one first? Then I would know what b is, and I'd have to go to something different. All right, so just don't be frustrated. You just sometimes have to try it. So I'm going to show you what happens if I would have chosen just the constants. Okay, so I have 5 over here equals 1a, and then the only constants I have over here is minus c. Okay, and again I had a, so a is 2. So that tells me c is negative 3. Okay, and again here, well, I'm kind of done. I have A, B, and C. Could I have used this? Yes, I could. I just think this one, these two, were easier. Okay? So now I have my A, B's, and C's. I can now integrate. Okay, so we have problem equals A over x minus 1 plus bx plus c over x squared plus 1. Okay, can I integrate that? Yes, that's that natural logarithm. Okay, can I integrate this? Well, hope so. What can I do with it? Can I separate it? Let's try that. So that would be x over x squared plus 1 minus 3 over x squared plus 1. Can I do something with that? Well, I think so. If I let this be u, my du is 2x dx. So what do I have? I really have du over u with an extra 1/2. So I'm back to the natural logarithm, so that's 1/2 times the natural log of x squared plus 1. But what the heck is this? I can't do the same thing. It's not natural log. You have to recognize that as arctan. So this is negative 3 times the arctan of x over 1 plus c. A little different, but not really that hard. Okay, I'm going to warn you now, this is just an ugly animal because this is quadratic that cannot be factored further and it's repeated. It's just ugly. We're going to get through it together. All right, so we would have to set that up as ax plus b over 4x squared plus 1 and then cx plus d over 4x squared plus 1 squared. So this is your repeated quadratic factors. Thankfully, you do not see this very often, but I am going to throw this one in. So again, if I take this original statement here and multiply everything by 4x squared plus 1 squared, I need to be really careful. So the left-hand side always ends up being the numerator. Then I'm going to put ax plus b in parentheses. And when I multiply this on the bottom with this on the top, it's going to leave me one of them. Then I have cx plus d, and I multiply this squared and this squared. They both cancel, and I'm just left with cx plus d. The bad news is I have 0 convenient values. So I'm just going to take a minute and clean up this right-hand side. I'm just going to multiply all this out. So I'm going to have 4ax cubed plus ax plus 4bx squared plus b plus cx plus d. This way I can see what all terms I have. So I start equating coefficients. So I'm thinking I'm going to start with x cubes. Okay, so if I have x cubed, do I have any on the left? No. What do I have on the right? That's it. So I have 0 equals 4a. So a is 0. Yay, done. What about, I'm just going to go in descending order, x squared. Well, I have 8 on the left, 4b, and then that's it. So I have 8 equals 4b, so b is 2. That's not so bad. All right, how about the x's? Well, I have 8x equals ax plus cx. Well, do I know either one of those letters? Yes, I do. I know a is 0. So now I know 8 equals to c. So I have a, b, c. I just need d. So I'm going to use constants because that's all I've got left. Okay, so I've got 2 equals everything that doesn't have a variable. Right? I know what b is, so that tells me d is also 0. So when I come back up here and I want to integrate these two things, a is 0 and d is 0. Let's see what that leaves me. Okay, so we have ax plus b. So a is 0, so I just have b. Okay, cx plus d. So c is 8, so that's 8x, and d is 0. Are these things something I can integrate? Well, again, if I let that be u, my du would be 8x. That doesn't work. What did we just have that kind of look like that? Arctangent. Okay, so I need to use this as arctan. So that would mean, let's see, a would be 1, u would be 2x, d would be 2 dx. Well, that's kind of nice. So I have it in the form of du over u squared plus a squared. That's just arctan. And arctan is 1 over a, so 1 over 1, times arctan of u over a, so that's just 2x. What about this next problem? Well, if I rewrite this as 8x times 4x squared plus 1 to the negative 2, and I let this be u, then du is 8x. So this is really in the form of a power rule. Okay, so my u would be 4x squared plus 1. I'd raise that to the negative 1 and divide by negative 1. So again, when you have all those quadratic factors, you're going to have to solve by the constants some way, either by equating coefficients, systems of equations, all kinds of things.